So, hello everyone. Please remember, students, to sign your name here, okay? So, in today's presentation, we're honored to have three speakers. Yes, three speakers at the same time.
All for the same price? Wow, what a deal.
So, it's Peter Ramsay, Doucet, and Chris Herbert. Each bring a unique set of expertise and accomplishment with the hydrographic and marine technology industries. So Pete has a PhD in marine geophysics and is a certified level 1 hydrographer under the Australasian Hydrographic Surveyor Certification Panel. He has 36 years of offshore industry experience and is currently the Director of Strategic Hydrographic System for Klein Marine System. Mo has a Bachelor in Computer Science and is the VP of the Software Development at Mind Technology. Mind provides technology to the hydrographic, defense, and seismic industries. He's responsible for the development of a new generalized architecture for building marine software application, as well as the lead developer for the SpectralAi software suite. In the last 20 years of his career, he's in the hydrographic industry. He has been responsible for numerous applications addressing all modalities of marine sonars. You can see like Chimera, FM midwater, FM geocooler toolbox, and others. There is a hand up in there, okay? And Chris, later but not least.
Chris.
Oh, hello. Holds the position of Chief Technology Officer at Mind Technology. Chris is responsible for directing the development of the company's next generation products, including SpectralAi. Chris developed the underlying machine learning model that is at the core of the SpectralAi framework. I hope you all guys enjoyed the presentation today. Please.
Thank you very much, Daniel, for that lovely bio on us. And thank you to Larry and Brian. We always very much appreciate coming to UNH. It's a great privilege for us. And another great privilege that we have today is we have the founder of Klein. Marty Klein is actually online at the moment. And Marty, if you don't know, is the father of side-scan sonar. So we're very proud to have Marty listening in on this as well. We still have regular communication with him. And we've got another side-scan expert in the room here. We've got Gary Kozak from EdgeTech. We very much welcome Gary to come and have a look at what we're up to. So the title of the presentation is obviously, AI-powered side-scan analysis, a new era of discovery. And this is not AI that you need to be scared of. So why would we need AI for survey data analysis? Well, we're finding now that with modern commercial and military survey applications, that the sheer volume of data that's required in a single mission or multiple missions and the rapid turnabout time makes AI essential component to your processing routine. There's an increased use of unmanned platforms, either in single use or swarms, and there's an increased demand for near real-time analysis and situational awareness without being able to broadcast the data back to your home base. Just to give you an example, we were chatting to a customer recently, and on a renewable energy project, a single geophysicist digitized 10,000 boulders. Well, I never in my life as a geophysicist want to ever digitize 10,000 boulders. So we're going to teach you about different ways of actually doing this without doing mind-numbing tasks like digitizing that level of boulders. So let me give you a bit of a background about the software package. It's SpectralAi. It's a deep learning for automatic target recognition. So we started the development of this a mere 3 years ago. And we finished this, and it is a commercial product. It's a new cutting-edge sonar suite, and it does the data management, the annotation, the mapping, and CNN analysis for automatic target recognition. We use a custom CNN model for our ATR. Chris is our neural network scientist who worked out how to do that. And our CNN is actually trained on sonar targets of interest. Whatever you're interested in, you can categorize it. And they're trained in the context of background. So, the surrounding area around that target, you're training it with respect to that. And the difference between SpectralAi and other packages that do ATR is that we use the full real 32-bit data. We don't use processed data at all. We don't use imagery or compressed data. So, if you look at sonar data rendered on a screen, you're lucky if you can see 8 bits in it. So we're going back to the raw 32-bit data. Just to give you a bit of a background of where Klein and mine technology all fit in. Prior to last August, Klein Marine Systems was actually owned by Mine Technology. I used to work there as well. And subsequently, in August, it was sold to General Oceans. But Mine Technology have actually licensed the use of this software for side scan applications to General Oceans and by implication to Klein. Right, just in terms of ATR philosophy, how would you tackle ATR just from a philosophical point of view? Well, if you have a look at these little charts here, you have data, and this is our Klein data, it's called SDF data. So we're going to annotate and classify it. We're then going to train a model and refine that model. We're then going to build it, and we're then going to run ATR. And then we use a process called active learning. So whatever the results that come out of the ATR, once you've reviewed those results and QC'd them, you can either feed them back into the annotation or feed them back into the model to build a much stronger model and a well-defined model. So using that philosophy, we developed 3 separate software suites. There's actually only 2, but I'll explain a little bit later. Scribe Pro does all of the management and annotation of your target data. Then if you want to take that target data and train an ATR model, you use Nexus, and that does the training and the modeling. And then Scribe ATR, which actually runs your automatic target recognition on your SDF data. And that's merely just an additional toolbar which sits in this package. So there's only really 2 utilities, Scribe Pro and or ATR and Nexus. Right, so what about the suite? What are the main features of it? Well, it's designed to run on all Klein sonar data and existing SDF data. If you have an old Klein 3000 system going back 20 odd years, you can use the data from that. As long as it's SDF data, we can use it. It leverages on a common user experience across all the products. So there's reduced training. So all the products have the same sort of menu features. We've got common projects across all the different products. We've got easy to read projects, solutions, target formats, and basically the outputs of it are JSONs and GeoTIFFs or PNGs. The whole, the utilities are written under an industry standard platform. We basically use a Qt architecture. And these 2 packages basically move the user from a manual workflow for side scan sonar data analysis into a fully automated workflow, which is going to save you time and money. And we're going to demonstrate this live to you. And also, especially for the academics around here, very fond of scripting, we have another utility called SpectralAi Command, where you can script all of these, all of the features in the software and run it in batch mode. So it's pretty useful. So how would you actually use this in an AUV situation where you've got an underwater vehicle with limited communications? Well, we've actually written a Linux version of this, which actually runs on an NVIDIA Jetson. And it's a small little computer about that size. That can be mounted in your AUV. ATR targets can be automatically generated from that. So it goes out and does a mission. And let's say the mission is to find mine-like contacts. It goes out, it finds mine-like contacts. It generates a GeoTIFF of that contact in a JSON file. Those are small enough. They're a couple of kilobytes to a couple of megs that you could send those by acoustic modem up to an unmanned surface vessel or back to your mother vessel. And you can implement mission changes or anything like that. So you're not sending up vast amount of data. You're just sending up the results from your automatic target recognition, which is very useful. So the data set that we're going to present, there's actually a couple of different data sets, but we're going to tackle the hardest of it, and that's looking at mine-like contacts. Mines are all sorts of different shapes and sizes and things like that. And we've done quite a bit of work with the NSWC in Panama City, and we have a crater with them on advanced mine finding. As part of this crater, I went out beginning of last year and collected 6 comprehensive surveys on various mine-like contact fields in the Gulf of Mexico. We used four different sonars. We used 3 single beams. That's the Klein UHR. This is a brand new sonar. We used the 4K survey, and we used the MaxView 600, which has the patented gap fill technology in it. And then we also used the Klein 5900, which is a military-grade multi-beam system, which is used for mine countermeasures. So if you have a look at the distribution of mine-like contacts in the particular area, one of the areas that we worked in, this is basically the distribution of mine-like contacts. So let's say there's a rough count of about 30 of these mine-like contacts. So that's really not enough to train an ATR model. So the way to get around that is to run a survey plan where each of those mine-like contacts is imaged from different distances and different orientations. So that essentially, makes sure that instead of having 30 samples, you now have 120 samples going into your ATR, which makes it a lot more statistically valid. So it's just a one way of actually doing this. And remember, we're surveying the same field with 4 different sonars too, at all these different line orientations. So we build up a pretty big database that way. But just to give you some of the results, this is done with the 5900. So this is a rather expensive dynamically focused 600 kilohertz multi-beam side scan system. And this is some of the data. So this is run at 75 meter range and 8.5 knots. And this is what this mine-like contact looks like. This is a Rockin mine over here. Here's a Manta. And this is, I'm not going to mention what type of mine this is. We're just going to call it a cylindrical mine. But it's quite interesting. You see these 2 attachment points on the mine, and they're the size of my fist. So you can see these 75 meters away at 8.5 knots. So, quite impressive resolution from a high-speed sonar like this. Then going on to the 4K UHR, which has a focused 900 kilohertz sonar. Again, some of the same features. There's this cylindrical mine. You can see these 2 attachment points, size of my fist. You can see some other nice features. This triangular-shaped Rockin mine. You can see the little tails on it quite nicely. And this is done at about 3 to 4 knot speed. Here you can see a 44-gallon drum with another pipe on top of it. You can see that pipe quite nicely. So very nice quality data that we were feeding into the system. All right, so now I'm going to hand over to Mo, who's going to do the live demonstration on SpectralAi. There you go, Mo.
Thanks. All right, I'm going to show you first SpectralAi. So as Pete said, this is an iterative process. So the first part is the boring part where you have to do your annotation because you want a bunch of good targets to do your model training. And Scribe is the primary application that you use to basically crowdsource all of your annotations. So let me start. I'll just run you through this. I'll create a new project. And then we'll add a bunch of data. As most of you know, I'm pretty much doing some similar things that we've done many times for applications where we work with folks here at UNH. Files are indexed. I hate playing back data. We want to be able to access data non-linearly. The traditional way is, okay, I'm just going to play back and play, but that might take me a long time to get through the data. I like to jump around. I like to see timelines. I like to jump to different areas. I like everything to be spatio-temporally synchronized. So all your displays, time and space, I know where I am, where my vessel is. I can jump right to a particular area spatially and start playing back that data to get to some target area. Or you can look at data in the preview. And the preview, if any of you have ever used iMovie, it's basically that metaphor where you can see the entire timeline, you can see all the data that you're looking at. Now, the key purpose of this application is to do your annotation. So here's one of the targets. One of the things that also should be noted is that Scribe renders the side scan data at full resolution off screen. So you can zoom in, zoom out, pan around. There's no decimation to the data. You can see it at full resolution. So this is the boring part where I want to create a target and I just box it off and then I get a target in my target editor. In here you can do typical things like, okay, I might want to crop that in a bit because you really want to constrain your target for machine learning to be the target and the shadow, the important parts. So you have cropping. I could move the geolocation point. If you have dual frequency data, which this is, you could set up the swiping tool so you can look in between, see what it looks like in low frequency, see what it looks like in high frequency. The data, whenever you create a target in dual frequency data, it's automatically created. Again, as Pete said, all of this information is in JSON. All of the targets are in the project JSON file. It's all readable. And the initial targets images that it creates are PNGs, and you can export geotiffs and bring those into the map. The map itself is an Esri powered map, so I could bring in different layers. You can have different layers, all the kinds of things you want to bring in, external geotiffs. If you have the license for it, you can bring in S57s, so all the fun stuff you want to see in a map. If you notice too, the temporal-spatial bit, as I'm moving here on the screen, I can see where my cursor is in the map. I know where that target is, and I also know where it is in the preview. Another thing you can do with dual frequency data, so not only can you see the target, with the swipe tool, but you can also use what I call, for lack of a better term, we called it a peek mode. So you can basically draw out a box in your side scan data, and you can peek through to see the other frequency. It's not as exciting in this. It's really cool with REX, because the low frequency, high frequency differential in REX is quite significant, and actually, as Pete's shown in some of his data, you'll see features that you wouldn't necessarily see in one frequency versus the other. So this was a fun little tool, and that's the enjoyment I get with working with experts, hydrographic experts like Pete, is Pete's the one that comes up with, man, if only we could, which is like one of my favorite things to hear from the people in the community, if only we could, because those of us that develop these kind of applications, some things are really simple, and you get huge bang for the buck for that. And that was one of them. It started with the swipe tool, and then Pete said, hey, could we do that in the waterfall? So we did it in the waterfall. Of course, there's loads of metadata. You get all the information about the survey, total survey time pings in the water. You get auditing. One of our customers was like, hey, we really want to know clearly what part of our data has been seen by the users. So there's a whole auditing system. If you notice, as I move through this, if I jump, there's this green bar that shows what I have seen. And one of the things you can do is you can export an auditing report. And that auditing report is just an Excel spreadsheet. But the key is, it not only audits the person that's looking at the data, it also audits any models you use against that data. Because you can use more than one model. So you could have a model trained for a certain set of class of objects, run it through your data, and then somebody gives you another model that they built, and you could blast through that data again with a different model, and it'll keep track of all that information so you can report on it. The other bit too, with the map, another thing that was asked by one of our partners, our early adopters, was that, hey, how do we make it so that the ATR ignores certain areas? So anybody that's used Esri knows that you can do geofencing, especially the guys, when you can think of folks doing surveys around wind farms, they might want to box off an area and say, hey, don't bother, around the base of the wind farm. We just want to ignore that. And when you're doing ATR, if you've got huge surveys, any areas that you want to exclude, then that makes it easy to exclude. So what I'm going to do, let me turn these guys off, is I'm going to draw out a box around this guy. I'll just do a square. and we'll say, let's just look in on this area. So I'm gonna just call that Geo1. You can do inside geofences or outside geofences. No, there's no Boolean for both. So you've got to decide which way you want to go. So we're gonna say that's an inside fence. You can tell, you know, I'm fancy, I love dashed lines that are, you know, 5 pixels wide, they're blue. So now I have a geofence in my data, and that I'll use when I run ATR. So imagine you've been through this entire data set, you've created a whole bunch of targets. There's 2 places you can do your classification. One is in the target editor. I can say, okay, that's a Milco, and I can go to this one and say that's a Milco. But we have something called the target catalog, which provides like a whole bunch of different filtering techniques by superclass, by class, description, title, etc. Any possible thing that you could want to filter by. But the cool thing about the target catalog is this where you do the normal, iPhone, I'm going to do a multi-select, click select, and then I'm going to go to the information and I'm going to classify all of those. So you can do batch-based classification. So you could go through all of your targets and then come back and then select the ones you want and do your classification. As all products that you guys are aware of that I love to build, it's completely customizable. Like I like to have my target catalog on this side. You can have things off in multiple monitors. So when I was at QPS, we call those workspaces, and I'm still doing workspaces. You can save those off. So if there's multiple users using the same product, you can load your favorite workspace and it'll arrange your windows so you get the type of workflow that you want. Of course, you can customize colors, you can customize control keys. Some folks love to use keyboards rather than mice, and you can do all of that. So if you notice again, the auditing, if I squeeze this all the way down, this is all I've looked at, so I haven't seen anything. But that is what gives you the feedback. All the other typical things that you want in a survey product, measuring mensuration for the target editor. You can add details, you can add tags, you can search by those tags. Lots of all the functionality that you want to find in a typical side scan application, which is actually where we started. Because we started building this application to solve the problem of, hey, the next generation of Sonar Pro and the next generation of side scan processing and acquisition. And then Dr. Huber was like, hey, I'm building this cool machine learning tool, but we can't seem to get anybody to give us any annotated data. So we sat down and went, well, what is it you need, Chris? Well, I need the binary data of the side scan, and I need to know where the location of the target is so I can train a model. And we worked together a short amount of time, and all of a sudden we turned that shit and started building in the total machine learning component. So that's a very high level view of Scribe. What I want to show you now is Nexus. So this is after you've done all of your annotation, and this could be many different people doing the annotation. And what I'm going to do is create a solution. And this is where a solution is effectively a project of projects. So you have surveys, and you'll have different projects. And when you're in Scribe, you're working in a project mode. But when you're in Nexus, you want to load all those projects. So these are all of the surveys that Pete did, where he did the painstaking annotation. So I'm going to load all those projects in. It brings them all in. It has all the references, has all the targets. So what you'll notice that's different with Nexus is the focus is not the waterfall. The focus is the target catalog, because the target catalog is what you're using to train the neural net. Now there's still a waterfall in here. You can still select that and jump to that location and go to that. We have all the data. So you can bring that up and see what the information is in context. Let's see the waterfall. Where are you? I'd have to reset it. I'll show you that later. But the other thing you're going to notice too is you're going to notice these dimmed out guys. Now, when you're bringing in targets from all of these different projects, what Pete did after his annotation is he went back through this and went, you know what, these targets are not necessarily ones I want to choose to train the neural net because they're ambiguous. It looks, to his eye, as a trained hydrographer, I can't really tell what that is. But he didn't want to delete them. So what you can do is you can just hide them. So you can hide those targets. So all of the things that are hidden are not going to be used. And then all the things that are filtered out are not going to be used for your training. So you'll notice here, if I squeeze this back over, there's 61 crab traps and 27 frames, blah, 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 403 milkos, 26 tires. So I could just say here, well, let's do tire and milko. So now I'm just looking at tires and milko. And maybe you say, well, I don't want to use this survey. That survey was kind of correct. Well, then that survey won't be included. So Nexus is really, really simple. Basically, all you do is slice and dice your data using the filtering to determine what you're going to use to train the neural net, and then you tell it to train. You bring up the training. This is where you can do a little bit more refining, like if you accidentally left in a class, you can uncheck it. Things like, Pete was like, I don't want to use the 300 kilohertz of the 4K. So we can uncheck that, and it won't include any of the 300 kilohertz. It gives you enough information so you know what you're getting. There's 26 tires, 180 milkos, and in this part here is all of the training. Now this is, there's extensive documentation about this, but there are some keys. One of the things you want to do when you're training is how do we carve up the data to feed to the neural net? And Chris and I went round and around this a few times, and one of the things that neural net loves is it loves nice square images that are, X meters by X meters, but they're square. Now, side scan data, the key is I know the cross-track resolution, so what I do is try to break it up, and this by default is 1024 pixels. So I find out what the a cross-track range of 1024 pixels is, then I move forward in time along track until I get that same distance. So the image might be 1024 by 360. But when I feed it to the front end of Chris's neural net, what he does is he stretches that out. And then a crosstrack will cut up a crosstrack so we get one greater than the division of how 1024 divides into the crosstrack resolution range. And we have evenly spaced overlap. But you can also tell it how much overlap you want along track.
Mo, are you stretching and resampling in the long track direction, or?
Chris, you want to answer that one, how the stretch works in your TensorFlow bit? For how we resample to the 1024 in a long track?
Let me think about that.
Okay, fair enough.
There's training epochs. So this is how many times TensorFlow goes through its training. And this is really how long do you want to wait around for this to complete. Patience is how many times will the val loss, and the val loss is how good the model does against the images that you held back. So you notice at the validation side, so what I'm telling the training system is that 20% of these targets, we shuffle them, and then we hold back 20%. And the val loss is how well the model's doing with that 20% as it's training. So what we want to see is that val loss descending continually. When the val loss doesn't drop anymore, the patience is what says, okay, after the val loss hasn't dropped 5 times, then just exit, you're done. And then we run something Chris calls mean average precision, MAP. And Chris can probably explain it to you later, but it's basically statistical analysis on how good the classification is for each class that you had. It's kind of what gives you, when we did this, we're like, okay, we need to give the user a warm fuzzy as to how good the model is. And MAP gives you that warm fuzzy that, okay, the prediction looks pretty good, false positives low, and things are feeling good, I could probably go with this model. So Nexus is basically this panel, and then once you're done your training, and I'm not gonna train it because we'd be here for hours, then you just build a model, and it takes the epoch that it ended on and writes that to a model that we're going to use in the ATR side. So this is a product you come back to when you have more data, when you're doing the active learning. So there was an experiment that we did because we were asked by customers, like, I don't want to necessarily go out and annotate 1,000 boulders to train a model on boulders. And we're like, okay, so there's a piece of machine learning called active learning where you continually retrain. You have a man in the loop going, okay, I'm going to train a model. I'm going to see how the model behaves. I'm going to get rid of all the stuff that's garbage. I'm going to do it again and continue to do that. So we had a site off of Poland that's World War I or II torpedoes and a lot of boulders. So we annotated 25 boulders and 25 torpedoes, trained a model, ran it on the data, and then I got about 40 or 50 of each with a bunch of garbage, so I deleted all the cruddy ones, trained again, then I got more than 80, and then after one more turn, found all the torpedoes, and I got like 300 boulders. So we're like, okay, active learning does work, but you got to make sure you, as the person in the loop, has to go in when you're in Nexus and go, no, 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 that's a bad classification. And what it does is it just enables you to kind of get there quicker using the AI, the machine learning, as kind of a crutch, as another person to help you do the annotation. So once that's done, now you're ready to use the model in a production way. And what you do is you go back to Scribe. I'll bring up Scribe. And what I'm going to do is I'm going to delete, I'll just delete these guys. So let's say this is a new data set that you have. The only difference between Scribe Pro and Scribe ATR is this toolbar right here. That's it. So what I'm going to do is I'm going to look at what model I have loaded. I can look at the information about that model. So that's the other thing too that we found very quickly is we kind of want reproducibility. So there are so many JSON files that get saved, and one of them that's key that gets saved is this piece that I call a recipe. So if somebody wants to go back and rebuild that same model and they have all the data, they can actually import the recipe into Nexus. Nexus will create all the projects, digitize all the targets, and have it ready to generate a model. Because you want to be able to go back to that state. So this is an example of one of the runs. This is the training. So we went for 24 epochs. If you look at the val loss, this is that key numerical value. It started at 1.04, and we got down to 0.68. The key is it was descending nicely. Everything looked pretty good. And then Chris's mean average precision, we were doing 98% on Milkos and 93 on tires. So, yep, I got a warm fuzzy that that's going to work. What I'm going to tell it to do is I'm going to tell it to use a geofence, so we're not here super long. I'm doing 50% overlap. So again, in the same way that I do training, where I carve up the data, and in the case of Nexus, I have JSON targets, so I tell the neural net in this piece of binary data, this is where the target is. So the neural net knows. It's just the opposite. So I hand the neural net, I do the same carving up. I hand the neural net that piece of binary data, and the neural net hands me a target back in image space. That using the JSON that has, ping, line, all that other fun geo stuff, it converts it back to basically ping space, so I know where the target is and can display it. So let's see. So we're going to do this in batch mode. So what you'll notice that you're going to see is you're going to see how the neural net carves up the data. You're going to see how it carves it up across track. Now we're doing a Zoom meeting, so this is going to crawl a bit because the GPU's getting a little bit of suffering. When we're not connected to Zoom, when this thing is, I think you're on a 3090p, I believe.
4090.
A 4090. We get about 5% of real time. So if you take the time it took to do the actual survey, the data will process in about 5% real time. So if we zoom in on this guy, so he's plugging along, and he'll stay within that geofence. So as the targets come up, let me bring that guy up and the target editor. So while it's pulling the targets in, I can jump to the location, I can see where that target is. And again, this is batch mode. So we can run in batch mode, we can run in what we call watch mode. So if you were doing acquisition, so if Pete had Sonar Pro running on the network, we could have SpectralAi on the network in watch mode. And what it'll do is as soon as a line completes and it's written to disk, so if Pete sets up 1 minute or 2 minute lines, it'll bring that in and it'll process the line and then just wait for another line to come in. So right now, this doesn't run in the place of Sonar Pro, it runs beside Sonar Pro in a live environment. What we're finding out, at least a lot of the initial folks, how they're using it, their SOP is they do post-mission analysis. So they'll go out and survey for a day and they'll process for a day. And they'll survey a day and they'll process for a day. So they're doing that processing after the fact and just using the projects that they created. This is an interesting target here. Remember we ran into, so you'll see there's a discontinuity where something just kind of crapped out. And I think this is in the high frequency. Yeah, the low frequency is fine. And the high frequency has that discontinuity. But because we train, remember when we create a target in dual frequency data, we create the data in both frequencies. And both of those are used, unless you eliminate it, both of those are used to train the neural net. So even though this had this weird discontinuity in the high frequency, it was still able to find that object. Let me close that guy. And you'll see, that these are all coming out as Milkos, even though that's one of the shapes Pete did. That's another guy, different shape, and that one. And I think this will go over some tires. Trying to think of what else we're missing. Oh, the batch mode, after we built this, one of our partners that we're working with, what they're interested is doing this in the cloud. So the first thing we had to do is build out the scriptable version of SpectralAi, and it has both. You can do training and you can do processing, all scripted. So if you have your projects, you can build a project with a script. So you can write out your batch scripts and just fire those off on a project with data, and it'll just run on the data in background. And I know a lot of folks, love to do things in batch. I think that's all the key bits. You think of anything else I'm missing, Chris, Peter?
This is just running in geological time at the moment because the GPU is being hammered by Zoom at the moment. So
if you guys hang out after, we can run this without it being connected to the web. We've got a lot of videos that show in real time where we're running.
Just show them the statistics of each of the targets, being the probability of it being a Milko.
Oh yeah, these guys. So there's another thing that happens. So as you see how it's carving up across track, one of the things you're going to think is that, hey, there's going to be a lot of overlap between, you're going to find a target in one of those boxes and another target in the box. So what gets fed in, the neural net gives us a probability of a particular class. Yeah, 93, 99, 99, another 99. I think I was on a 94. That's 100%. What Chris has is, Chris employed an algorithm he calls non-max suppression. And what that does is it takes in, it's a function of basically area and probability to determine what is the best example of the target. So that's why we don't get duplicates intraline. You can also have it, if you've done your own annotation, one of the options of the processing is to do non-max suppression on targets that you've created. So if you've already created targets, you can have the neural net override your target. Now you can lock them, this little lock icon here. I could lock that and then the neural net can't delete it. So you can have targets that you want that are fixed and locked, and non-max suppression won't catch them out. The next bit we're working on that we're just starting down the path on is what do we do about side scan, not intra-line, but inter-line. So he's coming back another direction. He passes over the same target, but due to good old, slant range correction and the cable out, if we've got some error bubble, we need to take that into account. We need to determine, are these actually the same target? So that's another bit that we're going to start working on, because this does a great job cleaning up in intra-line, but not inter-line.
Show the export mode as well.
Yeah, there's lots you can do. This is actually a really powerful one. So one of the exports we have is the project JSON. So when Chris and I are working on different surveys, we'll have the data on a shared Dropbox. So we'll have the same data, but I'll do annotation on some, he'll do annotation on another. And instead of sending somebody like the whole project, all we do is send them the JSON, and then they can import the JSON, and the system will go through and find out, okay, these targets were these lines, and you can have different directory structures that figures all that out. And what it'll do is it'll recreate all those same targets. So I can do annotation, hand Chris a newly annotated project, not have to ship him all of the data. He creates a project, loads the data that he has locally, and just imports my JSON file, and then it'll create all of those targets. And that's where this is the import JSON targets, this is the export JSON targets. We can export the auditing report. And it's not letting me do any of this because it's running ATR. We can export high resolution images. So the classic screen grab, right? When you have a sonar that's running 4K per side, and you do a screen grab, that's not nicely representative of the actual image. So one of the early things we built for Pete, and it's mainly used by marketing, is to say, hey, we have this really cool rec. Can we want to generate a poster of it? And yeah, we use a high-res exporter, and now you have, a 10,000 pixel by 24,000 pixel image, and you can put banners on it and rulers and all that other stuff. And that's a very simple thing, but then you get the actual resolution of the image, the native resolution. We can do PDF reports. PDF reports are classic in that I'm sure if somebody tries to do a PDF target export, they're going to say, hey, can we add something else to the header? There's a fixed set of things that Pete came up with that every surveyor wants, and that'll be in the export. And then we can also export ASCII files, because one of our other workflows from one of our customers was, hey, we then take the targets and we bring them into Keras and we generate ENCs. But we need to be able to import just a comma delimited Excel spreadsheet. So that's what that does. And that's another way we can get targets in and out, is through the exports.
Just look at the second last target mode that's pulled up a tire. Let's show that. Second last one. Third last one now.
That guy. Yeah. One of the really interesting things that Pete and I found was that after we trained the neural net, so that's the size of a target. So it's really, not that big. If I showed, there's pixel size as part of this, you'd see that's really small. One of the range scales Pete was running at with the 5900 was 120 meter range scale. And on a laptop, when you have a 120 meter range scale, that thing the human eye can't see. So one of the things that was interesting in our early testing was that after Pete did all of that annotation and we trained the model was actually finding things that an expert hydrographer missed. Because the human eye, I can't see that. You're just going to miss it. And that was a very, very pleasant surprise. Let's see, I'm just trying to see if there's any other bells and whistles that you need to see, there's multiple views of the waterfall. You can have a secondary waterfall window. The key is everything's tear-offable, so you can move them. You know, this is really meant if you want to have multiple monitors, you have a lot of windows up. Like I always have my target catalog off on another. You know, typical things, changing thumbnail size, you know, multi-select, click select, deselect, invert select, all the usuals. Maps, you can bring in Esri layers. They're, you know, like street maps. There's all of the go-to capabilities. I want to go to particular geolocation. I want to do measuring on the map. I want to do measuring in the waterfall. I want to make sure that the waterfall is speed corrected. You know, lots of all the bells and whistles that you'd expect when you're dealing with side scan data. So those are kind of all the big pieces. We basically wanted to create the ability to have a force multiplier to do one of the most mundane tasks out there, which is data annotation. And as soon as we disconnect from Zoom, I'll have people fire it back up and we'll run. You'll see actually how it runs on a laptop, which is pretty astounding given that with the new 4090s. I think we doubled the speed. So we started with 3090 GPUs, NVIDIA's, and we were getting about 6% real time. And then when we went to the 4090 GPUs, we doubled that speed. So just in one generation. And that speed differential really helps with training, which is the real, you know, that's the real expensive. That's where that data set that Pete had, you know, that's where you walk away for an hour, 2 hours while the system just grinds away and trains. So that's about it.
Yeah, thanks, Mo. Just in terms of closing, this is a full commercial package. It's in use by several navies around the world. We have a lot of orders for later on this year. It's also being used in the wind farm industry by some notable survey companies. So it's full production at the moment. If there anybody has any questions, I'll take them. Larry.
I'll start with the commercial question. I assume there's no reason this couldn't be used with other sonar systems. I mean, there's nothing.
It can't. We've locked it to SDF.
Well, you've locked it to SDF. That's a commercial decision.
Commercial decision.
Okay. So
For side scan.
what?
Or
For side scan.
Side, yeah.
For side scan, yeah.
For side scan. No, I was just curious. I assume you evaluated the trade-offs of forcing people to buy your sonar versus the market for this.
Yeah.
I just wanted to confirm that they will.
The thing is, it's designed around the SDF format and the raw data.
I understand that, yeah.
So,
Okay, thank you.
Do you plan to host, for example, once a widespread of people are using the software and training these models on different databases and stuff, do you plan to keep a trained model that people can use, or a model that can be updated by these users and made better?
we do not provide any models for the simple
At all.
reason is that a lot of models are ITAR controlled. So, and a lot of navies do not want you to have any access to their models. So our business model is we want to teach a customer how to build their own models, and those models are their IP. They actually own the IP to that model. So let's say that there's a company who does lots of renewable energy work, and they have developed a UXO and Boulder model. You know, that would be their proprietary information, and that gives them the competitive edge in the markets. Navies also never want to share models. It's just, they're all highly classified.
So you can think of Nexus as an authoring tool for those models.
Also, just a quick follow-up question. When you run that live validation, is it on the validation set that you put aside, or is that on the training set, on the set?
No, that's on an independent set that you saw here.
Yeah.
You can, there are utilities to basically compare. So you could do training on a certain set, create a new project with none of the targets, run the model, and then you can import and you can compare the project. Because what'll happen is, for example, like Pete's data has it was 6 different classes, but we're only using a model that was trained with 2, so you can tell it, I want to compare the project to to the original training set or vice versa, and you get stats on how good it was and how many it found, because that's how we get, again, our warm fuzzy of did it find everything that, at least find everything that we trained it on.
Yeah, there was just a question online here. Are these sonar models catered for side scan sonar images only? It only works with Klein raw data, so not on imagery whatsoever.
I'm curious about the training on this. Whenever I see AI presentations, I always say, so here's what we're looking for. So we went out and collected a whole bunch of those, and here's what we're looking at. But you can't train a model unless you also have the negative case in there. So you can't have just a bunch of positives. You've also got to know what a true negative looks like. How are you handling that?
The way we're handling that is, well, the way I'll answer that, and then maybe Mo can answer that as well, and Chris. But we found that having multi-object models gets you around a lot of that. Chris?
I would say the more technically true answer is that the way that we do this model, what this model does classification and object detection. Classification is there's something in this image and it is going to be of class A, B, C, person, dog, cat, car. Object detection is draw me the box around the object that you think is there. Okay. Now, you said you can't train it on a negative. The way that the training is done is that the imagery will be, again, some human will have to go draw bounding boxes. Okay. Now, when we are now giving it to the model to train, the model says, so this is a real big rabbit hole, but I'm trying to keep it to at least make sense to you, is that the way the neural network sees size and depth, right? Like if we can all imagine finding faces, like relative to me to you, you're much closer, so your face is much bigger than a person's over there. Okay, bring that back to the image. You have more pixels on your face than he has on his pixels over there, okay? How do you do that with a neural network though, right? Because the neural network just wants to draw a box around your head and around his head, all right? So the way the neural network says this is, I'm gonna take your image and I'm gonna break it down into a bunch of levels. Now I'm going to apply all these predefined anchor boxes. And we have hundreds of thousands of anchor boxes that go along each, that literally just cover the whole image, all right? Now the neural network says, I am now going to correlate all these predefined anchor box positions to all the predefined true targets that you've just told me. And then it goes through and it does all this. And then it says, okay, now, all these, I now have all these anchor boxes, right? Like I got 500,000 anchor boxes. Now, the vast majority of them are actually negatives, okay? Few of them will be positives, right? And then, again, the neural network then does, so it goes through its thing, right? Like it's gonna go through, it's gonna accumulate a loss function. And then again, there's sort of fancy math and how to balance out, because you really don't want to unbalance a neural network with, lots of one thing and then a few of another. And so maybe I'll stop there. But the answer is yes. Most of the things that it sees are negatives. It views these things as negatives, right? And so when it's trained as a negative, it will for every anchor box, it outputs a prediction. Is there something in me? And what class I think. I mean, it doesn't make sense to a human, but that's how these things work.
Yeah.
And so only when it hits a threshold, right, a score, a 0 to 1 score, that it will then say, okay, this particular anchor box, I think there's something in it, and then it'll look and say, what do I think is in it? And then it will say, I think, again, it will look at all the classes that model is aware of, and maybe it's aware of 2 classes, or maybe it's aware of 80 different classes, because that's what you trained it. And it will say, of the 80 classes that I'm aware of, this is the highest score. And it beats a threshold, 50%, 30%, 80%. And so then it declares a detection.
Thanks. That
Sorry, I
makes
know
sense.
that was really long-winded. I know
Yeah,
that might-
no, but it makes perfect sense to me. Thank you.
Well,
I have like 8 questions, but I won't ask them all, so it's not right off the bat. I guess my first question was about active learning that you talked about. So if you go through and annotate a bunch of images and then train and then use that to go back and infer detections on that original data set and then separate the wheat from the chaff a little bit manually and then go through that process again, is it right that you only see the things that you annotated incorrectly, but not the things that you missed altogether on your first run? Is that right? That
Just what I've seen when I did the active learning, and there's a LinkedIn post on this, is I see things that it mischaracterizes. For example, I didn't train it with enough torpedoes. So it's like, hey, this sand wave, that's a torpedo. But it's like
the discrete sand wave.
72%, right? But I go, nope, out.
if it was a torpedo and it thought it was a sand wave and didn't mark it, you would never see that.
But if I didn't,
It wouldn't draw your attention to it, I guess.
yeah, if I didn't have it so it's only ever gonna give me back the classes that I trained it on. So it's not gonna, I hope I'm understanding you, you're not gonna get other classes. What it'll do is I'll get basically a false positive. It'll think something is a boulder or a torpedo, and it's not.
It's the false negatives that I think you won't ever see. Those are the ones I'm worried about, not the false positives. I think you're right, false positives you'll catch, but the false negatives you might miss, and that
But what I
process is something to be
found-
careful about.
What I found is that, because what I was trying to do is basically trying to accelerate the learning. So my training set all of a sudden gets bigger. In this case, in that example, I think the training set like easily doubled in size for both boulders and torpedoes. And when I train, you could see it getting better and better at finding, like within 3, I mean, it wasn't a huge survey, but within, I think, 3 iterations, maybe 4, it found all the torpedoes, maybe missed a couple near nadir, and a ton of boulders. So I think the active learning thing, what I wanted to verify, is it real or is it just baloney? And when I found that it is a real thing, but I think it definitely needs more churn, especially on different class types.
And this, if I could just follow with one more quick question. Have you sorted out a way to integrate like scalar things into the convolutional neural net for detection? So for example, the common obvious thing to do with side scan images is try to measure how big the thing is. And you could imagine that going into the model in some way so that if somebody's throwing out, I don't know, like 55-gallon drum size mines and they're all 55-gallon drum size, that would tell you something more that would be obvious. Have you sorted out? Is that in there at all?
He's being, that's a good question. The thing I have seen is that scale, it'll find, so if I train on a particular boulders or the classic ones, I won't get all the same boulder size. I'll get small boulders that look like the boulders I trained on, and I'll get big boulders of the boulder type I trained on. I think of it in simpler, little kitty cat face, big kitty cat face. It'll go, that's a kitty cat. And it'll
what
find
it
out.
does is it also gives you a relative size. The size is not precise at the moment, but it gives you a relative size of that boulder. It's not precisely measured, but it's damn close.
And maybe that's a way to also trim.
The implication is that then size is not one of the criteria. for
Currently, yes,
identification.
yep.
Because of, you think of boulders, Larry, or
Well,
rigs or
boulders, yes, but
anything like that.
mine's not.
Yeah,
So
that's
something
currently
with mine,
not
you think
part of
that
the
would be-
training. Yeah.
That would be a real key.
Yeah. So that's a good, we'll pick his brain on that.
So I've got questions about what you're exporting out and sort of how much are you able to get out that size information and stuff through this automated process, or do you still have to go back through and manually go and measure these objects? Is that part of
So
it?
we got recently yelled at by one of our clients that wanted us to put a default measurement in. So right now, we don't, by default, I mean, you'll see a size, because it has a size, it's corrected, it's speed corrected. So they want us to go, okay, we want an option where it just says it's 2 meters by 2 meters. But those objects, torpedoes, the classic one, what we're looking at now is, this is more of an image processing problem, is how do you take a torpedo and go, okay, that's the length of the torpedo and here's the width of the torpedo. We're trying to automate that, because that is another painful part of annotation.
And we also want to measure the height of an object.
Yeah, the shadow height.
Yeah, so I was
And
wondering,
that's
with
gonna
the
be
water
going-
column, if you were doing anything automatically, since you're dealing with the raw data anyways, if you're able to like
What would be awesome
hide anything with
is,
that yet.
would be awesome is if some CCOM students were kind of working on that. That'd be a great project. for CCOM students.
So ignoring the AI part, for your traditional output, so what is going in that output? You mentioned PDFs.
Yes.
Yes, you get geotiffs, so you can, you mean the targets in particular?
Now, what are the exports?
Yeah, when
So
you're,
the-
so you found all this information
Yeah.
and you've annotated it in your software.
So you can export
Would you be able to
geotiffs.
actually export?
Yep, you can do ASCII, full ASCII with all of the attributes, plus a file name of what the geotiff is. You can decide to export a geotiff or not. So you can do ASCII for downstream processing like for Keras. You can export a PDF report that's pictures with a table of all the data. And you can decide what data you want to include in that. And additionally, you can also export the geotiff while you're doing that. So the main ones are ASCII and the geotiff. You also have the JSON information. So if you want to build your own importer of the JSON information, that is also all there. And that's part of the project.
One of the reasons I asked is that after Superstorm Sandy, there are a lot of contractors that went out and did side scan, and the only thing that the people that paid for it left with were PDFs. And we went through and we tried to scrape stuff out of PDFs in order to get lat
No,
one.
you get,
It was a pain in the ass, and they didn't have a, it wasn't a good alternative. I think that the companies would have exported something that would have been really useful for reusing that information for a different reason than why they originally collected it for. But that wasn't a good way to like make that machine reusable and like be able to get information out and say like, hey, this is where the stuff is.
yeah, so the target, if I go, let me just bring this up really quick. If you go to the target catalog, actually, let me bring up, can I bring up one of your?
Yeah, bring up one of mine. Just use the, just go to the projects. Yeah, there. Projects. Just go to any of those.
Yeah, the 4K survey.
Just export.
Yeah, so here, if you're using the target catalog, it's based on selection when you're exporting geotiffs. So from the target, there's a bunch of different places you can do exports. You can do it from the target editor, target catalog, but the keys are geotiffs, PDF, and ASCII. So, and in the project, if I go here, let me show you this. If I go open the project location and I go to targets, these are all just PNGs. So you get all the PNGs if that's useful to you. And if it's dual frequency, you'll have both frequencies of the information. And then if I look at this guy, just to give an example, that so I don't lose it. This is all the target information, and there's a pile of stuff. So we wanted to make this readable in case somebody wanted to pull information, but it's, position, line name, class types, computed space, there's a host of information. Top left, bottom right corner, with both ping numbers, times, positions. So we try to give you as much stuff as there was in case an export we had, wasn't there. But if there's a particular export, this, like all other products you guys know that I built, it has a plugin architecture. If we can create a plugin exporter that doesn't require us to rebuild the application, and we add an exporter to it that's to whatever specific flavor of information you want. But those are the keys.
That's important to be able to have something machine readable, not just a PDF.
Yes.
Then you can do
Yeah,
other
it is.
stuff.
Yeah, hopefully this is going to be the final question. This is just to follow up on Andriano's question where he was asking if you can use a trained model, like on another, on a new survey. Like, of course, I know you said, yeah, you don't want to do that because of privacy issues and all.
But like, I'm just thinking about this, is this something that would work? Like, train a model like on a different survey and use it on an enterprise?
Exactly.
Yes,
What we've found, Elias, that it is relatively frequency independent and sonar independent. So you can take one of the Klein very high-end sonars, which cost close to $1 million. You can develop a model using that sonar, and then you can use that model on one of the cheap Klein sonars, or vice versa.
Mm-hmm.
And we've tested that independently, and it works as long as you are if you're looking at small objects, as long as you're around the 500 kilohertz frequency and above, it works perfectly. But if you're running at 100 kilohertz, don't expect it to be able to do, Milko type detections.
Yeah, that's what I was thinking.
Yeah.
Thank you so much.
Let me just read this online one. Somebody had a
Gary.
great question. Are these models cater for side scan sonar images only? Right now, this application is for Klein side scan data. Again, we're not using the images, we're using the raw side scan data that's in the SDF file. So it's the raw port and starboard data, the time series data that's in the files. We're actually talking with Klein about, hey, should we add some secret sauce processing and train with secret sauce process data and then detect on that? One of the important things that we built in that goes along with the number of JSON files is when we create a model, the model has all the information about how it was created. So if you remember when I showed you Nexus, there's an image size, how it carves up that data. That way, when Scribe runs on your new data and you load a model, it goes, what am I using? How am I carving that data up? Oh, it's this size. Here's what I have to do. So all of that information is encapsulated into JSON. So now when we do the secret sauce Klein processing, so if we build a model on their process data, the model will be built, have that metadata in the model JSON, so that when the ATR goes to run, it'll go, oh, I need to send it not raw data, I need to send it the process data. So as we evolve, that's the whole reason why we went with JSON, because initially, the target JSON files probably expanded like every 2 months, we added more stuff to them. So then what we found out is that the model needed that, it needed that recipe so that we could go and reproduce that and we could extend it in the future.
Gary, you had a question.
Any chance of pulling up in a PDF of those samples?
Yeah, sure. Yeah, let me do that for you quickly. I'll just export it. I'm going to go target export to PDF. I'm just going to put this across here. So here you can select, what information you want in your PDF. Do you want all the targets that you wanted? You can sort your targets so you can only export Milkos. I'm just going to export everything. You can type in, where your survey area was. Do you want some padding around each of the images? But I'm just going to give it a name. I'm just going to call it Gary.
Well, while Pete's doing that, remember that when you're training the model on targets, you want that annotation to be nice and tight around the object in the shadow. When the machine learning finds the target, that's the target box you're going to get. But when somebody wants a report, they might want to see it in context. So that's what the padding's there
Hold
for.
it for a second, I just want to see.
Yeah, there's everything that we found.
I
So
want to see.
yeah.
And you could decide how many of the different metadata attributes you want exported.
So all of this is configurable.
Larry. So, guys, Larry's gonna be the last question, and feel free to stay, but if you wanna leave, you can go home, okay? Please, Larry, go ahead.
I just have a question about your experience with users and whether this is the end product. Is the position that you produce accurate enough for most users, or are most of the use cases where there is a follow-up with another camera survey or something that needs a more precise positioning or some other verification?
Let me on. Okay, so in terms of the positioning of it, that has got to do with the sonar data acquisition. So, if you're dealing with a relatively low-end customer, low-budget customer, he's using a cable counter, GPS, and that he's doing standard layback. The more advanced ones are using very expensive INS-based USBL systems, which are pretty robust these days, and that is determining your fish position. We are very shortly going to be implementing a post-processed fish position as well. So you could go in, you could do all sorts of fancy least square adjustments on your towfish position. You can then rewrite that back into the SDF data. So that would be fully processed, towfish position. And how you did that might be a blend of cable counter information, USBL information, however you want to do it. We don't really care at the end of the day how you want to do that.
Or we're making it so you can basically import and reprocess the targets and update their positions.
There's also, and this is at the very fine scale, but for some customers it may make a difference, is where you select the position within your target detection, automatic target detection.
Both of them are centered. Both for the ATR and for the annotation, unless you move it. Yeah. But the ATR just goes, hey, this is the position, it's the middle of the target.
But
I think that ties back to the other question of if we're gonna do automatic measuring, then that's where we would have to retarget back to the centroid of that, where that mass is.
Am I also understanding you, Larry, that you might not want to use your far field and your near field information? That can be done. It hasn't been done yet. That's going to be at another phase. So you might exclude your near field information, close to the nadir, and you might exclude your far field information, and that would be a user configuration. So we'd only deal with, that part of the slant range. Yeah. I think that probably answers your question better.
No,
Okay, so thank you so much.